So graph the transformation of absolute value functions. So f of x equals to absolute value of x. We're treating this function as a basic function. We're treating this graph as a reference graph. So we use this graph to graph g, graph this function. So remember, f graph looks like a V shape. We use the 3 points. We use the 3 points. -1, absolute value of -1 is 1 point. And we use 0, 0, absolute value of 0 is 0. And then we use 1, 1, because the absolute value of 1 is also 1. So we mark these 3 points on our graph. Let's use red color. This point, and this point. So the x value is -1 here. X value for this point is 1. And the y value here is 1. So we use these 3 points. Now let's graph g. So this is our f of x. G is a transformation of f. So let's see this. First, we see x is being pushed to the left for 2 units. X being pushed to the left for 2 units. So let's write down underneath here. When the x value is being pushed to the left, we do -1 for -1 for the first point. For -1 is -2, 1. So I have this point. The 0 being pushed to the left, 0 minus 1 is -1, 0. Then 1 minus 1 is 1 minus 1, that becomes 0, 1. So if we graph this one, so this is -1. Oops. Let's see, -1 is here, x value. Right. Then -2 is here. Well, I can graph on this one since I have a red color. For you, you try to graph on different grids, okay? So -2, 1. So that's this point. This point being moved to here. And the 0, 0 is being moved to here. And this point is being moved to here. So now if I graph this one, so every point is being pushed to the left, or 2 units. Sorry, I did a 1 unit. So let me change this question to be +1. I'm sorry, because it's so difficult for me to draw, use my fingers. All right, change the question. So I just, every point on the graph being pushed to the left 1 units. So once we have this, let me change my color to be green. I do the transformation of the negative sign. Negative sign is a reflection. Negative, so all the function values is being negative. So that means my points becomes -2, -1, 0, -0, still 0, and 1, -1. If I graph the 3 points, I would have this one. I would have -2, -1, this point, and -1, 0, this point, and a 0, -1, this point. So this is a -1 for y value. So I graph this one. So the green color shows the negative, the reflection over x-axis. And lastly, I'm dealing with this +3. +3 is a function value being pushed up 3 units. Right? So the function value, which means the y value, being pushed up. So now I have a -2. -1 plus 3 becomes 2. I have -1. 0 plus 3 becomes 3. Then 0, -1 plus 3, that's 2. So I have these 3 points. So let me use what color? Purple color. Let me use a purple color. So these 3 points, should be on the purple color. Or I change my color. I don't want to change my color. So -2, 2, -2, 2. Let's see, this is a 2. So -2, 2. I have this point. Then -1, 3. -1. Oh no. Yeah, -1. -2, -1. So this point, so -2, -1, this point being changed to be -2, 2, being changed to this purple color. And the -1, 0 now changed to be -1, 3. -1, 3. So this is -1, 3 is here. So let's make this graph a little longer. So this is a y value 3. So this is the point, -1, 3. Then 0, 2. 0, 2 is on the y-axis, right? So now my final graph is this purple color. Sorry, I don't have enough spaces, so I draw all the transformations on one graph, which you could do that if you use different colors of your different colors. All right, so let's just go back to review a little bit. So the first transformation is a horizontal transformation, is x plus 1. That means every point of this graph being pushed to the left 1 unit. So which is this red color. This red color. Then the negation is reflection, which is the green color. In the end, everything add up to 3, push up 3 units. Push up 3 units, so that's a purple color. So the final graph is the purple color graph. You could work with 3 points, right? That's the first one. Now let's see the second one. A quadratic function, right? Let's just remember. So I'm going to draw the reference graph in purple color and going backwards. Remember, quadratic, I said I work with 5 points. Quadratic graph, x squared looks like this. So we could work with a point 0, 0 on the graph, -1 on the graph, 1, 1 on the graph, 2, 4 on the graph, -2, 4 on the graph. Okay, could write down these points. So this one is 1, 1, and the top one is a 2, 4. This one is -1, 1. And the top one is a -2, 4. Now, oh, of course, the origin is 0, 0. The origin. Okay. So that's my x squared graph. Now I see x minus 2. So horizontal shift 2 units to the right. So I'm going to use blue color. Right. So every point being pushed to the right 2 units. 0, 0 now being pushed to the right 2 units. Let's see, 2 is here. 1 is here. Oh, actually, my graph is not in the perfect scale. All right. I want to use different color. Give me different color, please. Right. So 0, 0 been changed here. 0, 2 now. Okay. 1, 1 change it to be, so let's say this is 3. 1 plus 3, 1 plus 2, that's 3. So 3, 1 now. That's this one. 2, 4 now push 2, 2 plus 2, 4. So 4, let's see, 4 is here. 4, 4. Somewhere here. Actually, somewhere here, 4. Then being symmetric. -1 plus 2, that's 1. 1, 1, have this point. Then -2 plus 2, that's 0. 0, 4, have this point. So you know what, my increment is so bad, so the graph won't look so good. Right? So this is my horizontal shifting. Every point being pushed 2 units to the right. So after I finish that, I have this vertical shift plus 3. So every y value being pushed up 3 units to up. So that means the y value at this point push up. So let's see, this is 1, this is 2, 3, 4. Let me just mark 4 here. Mark 1 somewhere here. Right, being pushed up 3 units. So this 2, 0, this point pushed up 3 units. This is 3. So that's here now. Right. Every point being pushed up 3 units. Every point being pushed up 3 units. This point being pushed up 3 units. This point being pushed up 3 units. You see the shape of the graph stays exactly the same. Just everything being pushed up 3 units. So in this case, the green color is my final graph. It's the graph for this G. Now let's see C. We want to use square root of x to graph this. So let's identify. Horizontal shifting to the left, 3 units. Right? Then dilation, every y value being doubled 2. Then we push down the graph 2 units down. So let's graph square root of x first. We use 3 points, right? We use 0, 0, 1, 1, and 4, 2. So that's it, 2, 3, 4. So this is a 4. This is a 1. 4, 2. Let's see, this is a 2. So we use these 3 points to graph square root of x. The change color to be red. So first, x plus 3. X plus 3, everything shifted to the left 3 units. So 0, 0, shift, let me mark 1, 2, 3 first. So I have -3, -2, and -1. 0, 0 point be shifted to be -3, 0. 1, 1 shifted 3 units becomes -2, 1. And 4, 2 being shifted 3 units becomes 1, 1, 2. Right? The graph stays the same. The graph stays the same. So these 3 points being shifted 3 units to the left. Now, let's do the dilation. Dilation means every y value being doubled. Let me type in these points. So get -3, 0. -2, 1. And this point is 1, 4. Okay. Compared to the green color. Now let's graph blue color. Blue color. So multiply the y value by 2. Well, 2 times 0 is still 0. So I still have this point. I still change color. I still have this point. Right? I still have this 0, negative 3, 0. Because 0 times 2 is still 0. Okay. But then another point is this point. Multiply 1 by 2, that's negative 2, 2. So this point now being changed, being raised here. And this 4, 2 times 4 is 8. 8 is somewhere here. So the graph's been dilated, which means the y value doubled before. So this is a graph of 2 radical x plus 3. X plus 3. So the green color is square root of x, radical x. The red color is the square root of x plus 3. Okay. Now lastly, we have the minus 2. So that means every point being pushed down 2 units. 2 units. Let's see, this is 1 unit, this is 2 units, that's negative 2 on y. So this point being pushed down 2 units is here now. Oh, let me change my color. Let's change it to be this color, purple color. So push down 2 units, become here now. This one push down 2 units, so on x-axis now. This down pushing units, that's on 6 now. Because before it was 8, right? 1, 8, now it becomes 1, 6. So I graph it. I try to make it smooth, not a straight line. Right. So that's my graph. Of course, it keeps going. We can indicate it with an arrow. So the purple color is my final graph of 2 radical x plus 3 minus 2. Now let's see the D. D, we want to use x cubed. So x cubed looks like this. Right, I didn't talk about this in class. The class work doesn't include in this. X cubed graph looks like this. In the first quadrant, smooth, then wiggles at the origin and goes like this. So we also want to graph with a couple points. Right? We see 1, 1, negative 1, negative 1, 0, 0 is on the graph. Let's use these 3 points. So first, let's do this half of x cubed. Before was 1, 1. Let me just type it in. 1, 1. This one down here is negative 1, negative 1. And the origin, of course, is 0, 0. But now 1 is being halved because we have a half x cubed. The 1 cube times half, we have half. So now this point becomes this here. And negative 1, same thing, becomes negative 1, negative 1/3. So the graph goes like this. I could do more points. I could. But for these 3 points are good enough. The origin doesn't change. Drive this graph. So that's my half x cubed. Now, lastly, I have to add 4 to it. So let me use another color. Let me use green color. Every point being pushed up 4 units. Let's see, this is a 4. 0, 0 now becomes 0, 4. 1, half. So this one is 1, half. on the blue color, right? 1 comma half, now add 4 to it, becomes 1 comma 4.5. And this is a negative half. Well, negative half becomes negative half plus 4 becomes 3 comma half, right? 3.5 is somewhere here. And my graph still have the same shape. My graph still looks like this, not straight, all right? Curvish, going through these 2 points. Then we goes at that and goes this way. Okay, it's better to write down those points. So this point is 1 comma 4.5. Let's see, 4.5. And the origin is still origin, right? 0 comma 0, still the origin. Oh no, I don't want to type in this one. Actually, I want to type this one. 0 comma 4. 0 comma 4. Right on my graph. Then this point, -1, -1, 3.5. So I want to type in at least these 3 points on the green one. So the green color is the final graph for g of x. Now let's look at 9, piecewise functions. Piecewise. Why is piecewise? Because the domain is split into 2 parts. Okay. Let's graph 0 in the middle. Let's graph -2 somewhere on the left-hand side of 0. Then when x is less than or equal to 2, because I have equal sign, let's make a solid dot. Until -infinity, the function is 2, constant function. If it's greater than 2, I make open circle, because not equal to 2, greater than -2, the function is defined as 2x plus 3. So I have 2 domains, so I have 2 intervals, and on each interval, the function defined differently. On the first interval from -infinity up to -2, defined as a constant function 2. From, oh, what did I do? Not above 0, above 2, right, above here. Not this one. I don't know why I draw above 0. Not equal to -2, but as long as bigger than -2 is defined as 2x plus 3. Right. So if we want to graph this, how do we graph? X-axis, y-axis, -2 is somewhere here. From -2, so let's see, this is 2. -2 to solid dot, because -2 is in the domain of this part. Horizontal line until infinity. 2x plus 3. So at -2, -2 times 2, that's -4, -4 plus 3, that's -1. So the graph starts somewhere here. Okay, let's see, this is -1. But with an open circle, because -2 is not in the domain of this one. And then give another point. Let's see, x equals 0. If x is 0, I have y equals 3. And let's see, this is 3. So I connect those 2 points. So I have this function. So if the x value is greater than -2, I have this piece. If it's less than or equal to 2, that's a constant function 3. So this is a graph of A. Similarly, for graph of B, let's identify 1. So let's see, 1 is here. If x is less than 1, that's 2x, right? If x is 1, that's 2. So we make an open circle. Let's see, this is 2. We make an open circle at x equals 1. And if x equals 0, if x equals 0, 2 times 0, that's 0, right? So that's this point. So the graph less than 1 is just this graph, 2x. If x is greater than or equal to -3, 1 that equals to -3 is a constant function. Well, let's see -3, let's see this is -2, -3 is here. If it's greater than or equal to 1, that means a solid dot. -3, constant function, horizontal lines. So this graph of this B, the function has this graph, also 2 straight lines. Now let's see C. C and D. So C, also 2 pieces. So that's a graph, x-axis, graph y-axis. Now the divider is 3. If x is less than 3, that's a quadratic x squared, right? If it's 3, let's see, this is 3, 6, 9. Okay, so this is 9. Add 3, because 3 is not in the domain of the first one. So I have this. Okay. Remember the quadratic function? Upward parabola. Symmetric on both sides. This one goes to infinity, negative infinity. So that's this piece. When x is less than 3, we have this quadratic. When x is greater than or equal to 3, we have 3x plus 2. So if x is 3, 3 times 3, 9, 9 plus 2, 11. 11, let's see somewhere here. 11, start with 11, with a solid dot, right? Because 3 is in the domain of the second interval. Then I need one more point. Well, 3 equals to x equals to 4. 3 times 4, 12. 12 plus 2, 14. Let's see, 14 is somewhere here. So I have this straight lines. So this represents 3x plus 2. 2 pieces. Let's see D. D, I have 3 intervals. -3 and 4. Let's graph. Let's see, -3 is somewhere here. +4 is somewhere here. So I have 3 intervals, right? X less than or equal to -3, that's quadratic. Or equal sign, so -3 squared is +9. Let's see, this is 9. So I make a solid dot, right? Make a solid dot. And remember this graph, remember the quadratic function graph looks like this, right? Make a solid dot on this. This is quadratic. Then from -3 to 4, that means from here up to 4. Not including those 2. So I gotta make 2 circles on both ends. That equals to 5. So where's 5? Let's see 5 is here. So starting from -3, but not including -3, I make an open circle up to 4, not including 4. I'm making open circle on top of 4. So in between, in the interval -3 up to 4, I have this constant function, 5. Greater than or equal to 4, I have x minus 1. So when x equals to 4, 4 minus 1, that's 3. Let's see, 3 is somewhere here. I make a solid dot because 4 is in the domain of this last interval. Then I need one more point. Maybe I say x equals 5. X equals 5. 5 minus 1 is 4. So a little bit higher than this. Okay. So I have this graph. You see 3 intervals. So these are 3 pieces of functions. So I have 3 pieces of graphs. Okay, I'm going to take a little bit rest and talking about exponential functions. Okay.